Hello friends, welcome back to my YouTube channel. This is Assistant Professor Ramdas Pandit Bhasad. In this video lecture, we are going to study about degree of ionization and it is denoted by alpha. Now you will think what is meant by degree of ionization. If you take any kind of molecules, so the separation of that atom from this molecule, fraction of that atoms from this molecule and dissociation of the atoms from these molecules. So this is the degree of ionization that we are going to study in detail now. Now you will see the proper definition for the degree of ionization, that is the fraction of total number of molecules of the electrolytes that split or ionize into the cations and anions is called degree of ionization or degree of dissociation. Now you will take for example HCl. HCl is molecules and you will dissociate for that HCl, you will get H plus and Cl minus. So H plus and Cl minus are ions. H plus is the cations and Cl minus is the anions. So this kind of degree of ionization with them we can see for the different kinds of molecules. Now formula for the degree of ionization, that is number of molecules ionized or dissociated divided by total number of molecules. Okay, now you will see this kind of reaction. This reaction NaCl is the solid in state plus water in liquid in state. It gives Na plus aqueous plus Cl minus in aqueous form. So when you are adding this salt into the water, so we are getting a ions, dissociated ions. You will see the fraction of these ions from this salt. Na plus is the cations and Cl minus is the anions, because Na having a positively charged and Cl minus is the negatively charged. So you can say easily here is the dissociation of ions. Okay, now see the second reaction, MgCl2 in solid state plus water in liquid state. It gives Mg2 plus in aqueous form plus 2Cl minus again in a aqueous form. Again you will see MgCl2, you will dissolve into the water, you will get Mg, its cations which having plus positively charged, okay, and Cl minus having negative charge, so it is the anions. Okay, so like this dissociation you can see when you will dissolve the salt into the water. Now see the next reaction, that is you can see here acetic acid in liquid state CH3COOH plus water in liquid state gives CH3COO minus in aqueous state plus H plus, okay, aqueous. So again you will see the dissociation of these molecules. Here is the minus and here is the plus signs, okay, fraction of these molecules. Okay, so you can simply say the molecules of electrolytes when dissolved in an aqueous solution, they get separated from each other, positively charged and negatively charged. So we call them as a cations and anions. Now this kind of phenomenons we call them a ionization or dissociation of electrolyte. Okay. Now one more thing about the degree of ionization, that is the degree of ionization usually increases with the dilution and its value becomes maximum at infinite dilution. It means you will increase the dilution of any kind of solution, you will get different kinds of ionization or degree of ionization, degree of ionization. Now we have seen the ions produced by the ionization of electrolyte. Okay, it may be ACl, it may be MgCl2, okay, it may be acetic acid. So they can combine back to molecule also, and this condition we can call them as a ionic equilibria. It means after the dissociation they will convert into come back into the molecules. Okay, so this condition we call them as a ionic equilibria, right? Now we have to see which factors are affecting the degree of ionization. Okay, in that the first one is nature of electrolyte, and we have know what is meant by electrolyte and their types. It may be strong electrolyte, it may be weak electrolyte, it may be moderate electrolyte, and we have seen in that some electrolytes are completely dissociated into water, and some electrolytes are partially dissociated in water, and some electrolytes like moderate electrolytes which require some condition like temperature and concentration. So nature of electrolyte is also affecting on degree of ionization. Now second factor, that is nature of solvent, and we have no solvents having solvating power. Okay, and one more thing, dielectric constant. Now we will take for example water. Water is the universal solvent. That means number of substances are dissolving into the water because which having high dielectric constant and high solvating power. That's why it is a universal solvent. And you will take second example like benzene, so which having low dielectric constant. Okay, now third factor we are going to see, that is concentration of electrolyte. Now in this case, if you will increase the dilution, you will you will get the number of ionization is more. Okay, that means when you are diluting the different kinds of solution, okay, that means ions are forming, and that ions may be positive and negatively charged, and they are go away from each other, it due to its attractive as well as repulsive force between the ions becomes negligible, and dissociation or ionization increases. So for the degree of ionization, the concentration of electrolyte also affecting. Now next one, that is the temperature. Temperature, if you are increase the temperature of any kind of solution, you will get more and more ionization. Okay, that means the degree of ionization, and we are giving the temperature to the specific solution, that is the endothermic process. It is absorbing the heat from the outer side. Okay, now next is, that is presence of common ions, and because of this factor reduces the degree of ionization, also known as a common ion effect. For example, you will take the ionization of ammonium hydroxide decreases in presence of ammonium chloride. Okay, now we are going to see the next topic, that is ionization of or ionization constant of weak acid. Now we will consider an ionization of weak acid Ha in aqueous solution. Its equilibrium is represented by this equation. You will see here Ha plus water. It gives H3O plus and plus a minus. So in this case, water is a having amphoteric in nature, so it will be basic in condition, so it will accept the H plus ions from this species, and you will see here which having extra H, okay, H3O plus. Now applying the equilibrium law, and equilibrium constant is the K, we have know that, okay. So you will arrange like this equation: the concentration of H3O plus and A minus, okay, divided by concentration of HA, okay, and the concentration of water, okay. Simply you will see the product divided by reactant, okay. Product you will see from this product, and reactant this one reactant. We have to simply arrange in this way. And one more thing, we have taken here brackets, okay, extra bracket here. So meaning of this bracket is the molar concentration of each species, okay. Concentration of these four species, 1 2 3 4, okay. And in a dilute solution, if water is present in a large or excess amount, its concentration may be taken as constant, okay. And K, and the concentration of hydronium ions is equals to the concentration of H plus ions, okay. And you will get here K is equals to the concentration of H plus, the concentration of A minus, divided by concentration of HA and concentration of K, small k. Now taking constant term in a one side of equation, you will get capital K into small k and concentration of H plus and the concentration of A minus divided by concentration of HA, okay. Now this is the dissociation constant for the acid, okay, is equals to, you will see here, capital K into small a, and we can say here the product of two constant is equal to the another constant, okay. That means you will write in this way also here, okay. Capital K into small k is replaced by Ka, okay, is equals to the concentration of H plus, the concentration of A minus divided by the concentration of Ha. And in this equation, Ka means the ionization constant of weak acid, and hence the ionization constant of weak acid is characteristics constant, and it is equal to the product of molar concentration of hydrogen ions and anion divided by the molar concentration of unionized acid. And in this case, dissociation constant for the weak acid of is related with the degree of ionization, that is denoted by alpha, that is the Greek, okay, and the initial molar concentration also. Now you will consider the ionization for the weak acid. So acetic acid is the weak acid, we have know that, okay. Dissociation you will see CS3 C double O minus plus H plus. Now the initial molar concentration, that is for the acetic acid, is small c, and here is for the anions is 0 and for the cations is 0. The concentration at equilibrium, that is for acetic acid, is small c in bracket 1 minus alpha, and for the anions small c alpha, and for the cations is small c alpha. That means the equilibrium concentration of an ionized acetic acid is equals to C bracket 1 minus alpha, and equilibrium concentration of anions and cations both are equal. You will see here small c alpha, small c alpha means both are equal. Now we have to apply equilibrium law here. It means by the law of equilibrium you will get a dissociation constant for the acetic acid. For weak acid you will see the concentration of anions and concentration of cations divided by the acetic acid. It is the product and this is the reactant. Product divided by reactant. Okay. Now putting the values of this concentration at equilibrium, you will get this kind of things. Okay. Dissociation constant Ka for the weak acid, it is C, small c and alpha into alpha into small c. Okay, and the same you can write in this way also, no problem. So divided by small c in bracket 1 minus alpha. Okay, so you will get A is equals to c alpha square divided by 1 minus alpha. Now you will see the relation between this term. Okay, ionization constant of weak acid, that is Ka, we have know that. Okay, ionization constant of weak acid, and the alpha means the degree of ionization here, alpha. Okay, and the C means, small c means the initial molar concentration of weak acid. Okay,